Hello, ladies and gentlemen. Welcome back. Glad you could make it. Welcome back to our channel where my name is Mr. Thompson. I'm here to show you that bow ties are cool and math is fun. Let's get rolling on today's lesson about dilations. Now, for today's lesson on dilations, all we're looking at is the fact that a dilation is simply a change in size. Whether you're enlarging something or you're reducing it. Whether you're enlarging it or reducing it. Dilation is simply a change in size. It does not produce symmetrical figures. I'm sorry, let me change that. It does not produce congruent figures. It produces symmetrical figures, but not congruent. So the figures are, symmetrical. Symmetrical means they're left and right. What am I saying? What is going on? It produces similar figures. Similar figures, not congruent. All right, ladies and gentlemen, let's start this one again. It produces similar figures, not congruent. Similar figures, not congruent. And two things that we have to know in this case. One, we have to know our center of dilation. We need to know that point that it is dilating out from or back into. We need to know that point, that center of dilation. The other thing we have to know is we have to know our scale factor. How much are we increasing or decreasing by? Now, scale factors greater than 1. Scale factors greater than 1 are enlargements. Scale factors between 0 and 1, those are reductions. Those are going to be your reductions. All right, ladies and gentlemen, we're looking at finding the scale factor from an image and a pre-image. So we're given our pre-image, triangle ABC, and we're given our image after some type of dilation. Now, when we look at finding the scale factor is always a division problem of image over pre-image, image over pre-image, new over old. Think about it alphabetically, N comes before O in the alphabet, new over old, or image over pre-image. So in this case, in triangle ABC, we see that side lengths here are 4. Then when we enlarge that, we see that our side lengths for A prime, B prime, C prime is 12. So our image over pre-image, 12 over 4, new over old, 12 divided by 4 says we got a scale factor of about 3. All right, ladies and gentlemen, our next example, before we get into the practice, we're still looking to find scale factor. But in this case, our pre-image is going to be the larger figure, and we're actually reducing down to our image. So as we see here, triangle ABC, our pre-image, and triangle AED, our image. What has changed? Now, looking here, we see that AD is 4. We see that DC is 8. So we need to figure out, okay, what is the total length here of our pre-image? So we have to add each of the 2 segments. Then we're going to do image over pre-image, image over pre-image. So for our image, we're looking at side length 4. Pre-image, 4 plus 8, or our AD plus DC. Add all that up, we have 12. 4 over 12. That simplifies down to 1/3. So we've got a reduction. Got a reduction by a factor of 1/3. Ladies and gentlemen, now it's time for practice problem number 1. Ladies and gentlemen, using mapping to help us determine the new grid coordinates, the new points after the dilation. When you're using mapping, you must know the scale factor. So we're given a scale factor, in this case it's n. So n, our scale factor, when we multiply that times our x and y coordinates, the mapping is going to look like xy maps to n times x, comma, n times y. We're going to multiply both x and y by that same scale factor. So, ladies and gentlemen, we're given our pre-image triangle PGH. And what's going to happen is we're going to multiply that by the scale factor of 2. So we take our grid coordinates for P, G, and H, and then multiply each coordinate by 2, x and y by 2, x and y by 2, giving us our new P prime, G prime, and H prime. Once we have those points, we can go ahead and plot them on the coordinate grid, connect them, and we have our new image after a dilation with a scale factor of 2. Now time for practice problem number 2. Ladies and gentlemen, our last example for today, we're going to be using the mapping again to find our grid coordinates based on a reduction. So we've got trapezoid here, RTVX. And what's going to happen is we are going to dilate this by a scale factor of 3/8. So 3/8 the size. We're going to bring this trapezoid down smaller. And what's going to happen is we're also going to use the origin, 0.00, as our center of dilation. So everything's coming back closer to the origin. Same as we did before, we'll take our 4 grid coordinates. This time we're going to multiply each of them by our scale factor of 3/8. Multiplying each by our scale factor of 3/8, giving us our new grid coordinates. And notice we are going to have to plot some 3/2 and -3/4 as our grid coordinates. That's okay. We can plot fractions. No worries. We'll go ahead and plot those grid coordinates, connect them up, and we see that we now have a reduced image. We've taken that trapezoid and we've made it smaller. We brought it in closer to the origin. Ladies and gentlemen, that brings us to the end of our examples for today. I'd like to thank you for watching and ask you to please subscribe to this channel and turn those bell notifications on so you can see when I create new videos to help you with your math course. And as always, I hope you have a fantastic rest of your day. It's now time for practice problem number 3.